In this lesson we're looking at our final method of integration. We're looking at integration by parts. Now really what we're looking at here is a situation where we need to integrate a product of functions. For example, we could be looking at an x squared ln x, trying to integrate that with respect to x. Now the issue is that the internal function doesn't have a derivative relationship with the external function, so we cannot use the substitution rule. It's obviously not a partial fraction situation, so this method is for when we have a product of two functions. So we're going to go back here and we're going to consider the product rule of the derivative. So you can see what I've got here is that the derivative of two functions, u multiplied by v, is v multiplied by du dx and u multiplied by dv dx. So that should be a known rule. Now what we're going to do here is we're going to try and derive the method that we're going to use for integration by parts. So we're going to try and isolate a product. So the first thing we'll do here is we'll look at taking the integral of both sides. So we're looking at the integral of d dx uv dx and the integral of v du dx plus u dv dx with respect to x. And so this is obvious that the integral of uv is uv, and then we've got the integral of v du dx with respect to x, and we've got the integral of u dv dx with respect to x. Now really the process here is that we're going to isolate, so we're going to subtract this integral of v du dx and we'll end up with the integral of u dv dx with respect to x is equal to uv subtract the integral of v du dx. Now this is our method of integration by parts. So the whole idea here is when we look at an integration by parts, we have to determine one function where we'll need to find the derivative of, and then we've got one function that we'll look at finding the integral. So this is function 2. Now obviously this process is the most complex process with integration by parts. There's lots of little extra processes and techniques that we can use, but this is a basic premise. If we can do this, then we should be able to come up with an integral of the original. Now it may involve some repetition or iterative processes, it may involve a little bit of creative manipulation, but this is our goal. Now when we start these questions, you're going to have a choice, and that choice is you need to choose a function to be u, and you'll have to choose a function to be dv dx. There's lots of different approaches for making this choice. The best one that I have found is using an acronym LIPIT. And when we look at this, so LIPIT to choose u, and obviously the other one will be dv dx. So LIPET, so L, the first one being logs. So any logs will always be u. The second one is inverse trig. The third one is powers and polynomials. E is exponentials. And then T is trig. So these last two are interchangeable, so the last two are not so important, but definitely the first three make a big difference, choosing them over the others. Okay, so what I'll do is we'll go through a really quick example, and then we'll have a second video that has some more complex and a few extra examples. So we'll call this example 1. Looking at the integral of x squared ln x with respect to x. Alright, so in this situation, looking at lipid, we can straight away define u as ln x, and we can define dv dx as the other term, which is x squared. So what we need to find first is the derivative of u, so du dx. The derivative of ln x is 1 on x, and we have to find the integral of dv dx. So find the integral, which allows us to determine the value of v. So that means that add 1 to the power and divide by the power, we've got 1/3 x cubed. And so now what we need to do is sub into the rule that we have and perform any integration that's required. So the integral of u dv dx with respect to x is equal to uv subtract the integral of v du dx with respect to x. Okay, so we're looking at the integral of x squared ln x with respect to x is equal to u times v. So we've got 1/3 x cubed ln x, and subtract the integral of v du dx. So v is 1/3 x cubed, and du dx is 1 on x, and this is with respect to x. Now this integral, hopefully, is something we can do. In this case it is, not in every case. So there'll be other approaches where you'll have to go through an iteration process, or you'll have to manipulate to be able to find the integral. But in this case, we can do it straight away. We'll simplify first. So this is 1/3 x cubed ln x, and we've got the integral of 1/3 x and x cancel to give us just x squared. So the integral of x squared with respect to x. We then have 1/3 x cubed ln x, subtract 1/3 x to the power 3 on 3 plus c. We've got 1/3 x cubed ln x, take 1/9 x cubed plus c. Now if we want to simplify at the end, and you'll need to get used to simplifying as much as you can, I can take out a common factor here. So I can think of this 1/3 as 3/9. I can also take out a common factor of x cubed. So we've got 1/9 x cubed, and then inside we have 3 ln x, and subtract 1 plus c. And there's our integral. That's the process of integration by parts. The rule is important, the choice of u and dv dx is important. Making the right choice at the start makes the integration easier and makes it less likely that you'll have to go through extra iterative processes or unnecessary processes to make it more difficult to find that integral. Okay. So the next lesson that will follow on from this will be a collection of examples with different scenarios and complexities. Alright, thank you for listening to the lesson.